This video is Stats 1, Section 1.4, Experimental Design and Ethics. So we're going to talk a little bit about a whole bunch of things, but start with experiments. These are things like, does aspirin reduce the risk of heart attacks? Is one brand of fertilizer more effective at growing roses than another? Is fatigue as dangerous to a driver as the influence of alcohol? Questions like these are answered using randomized experiments. We will look at important aspects of experimental design. Proper study design ensures the production of reliable, accurate data. The purpose of an experiment is to investigate the relationship between two variables. The explanatory variable is the variable that causes the change in the other variable. And the response variable is the variable that gets change. It responds to the explanatory variable. So in a randomized experiment, the researcher manipulates values of the explanatory variable and measures the resulting changes in the response variable. The different values of the explanatory variable are called treatments. An experimental unit is a single object or individual to be measured. We're going to go over some examples. Sometimes these words are a little strange because sometimes we're talking about people, and those are the experimental units. And the things that they're given or that happen to them are the treatments. So here's an example, our first example. Researchers want to investigate whether taking aspirin regularly reduces the risk of heart attack. So we're going to identify the following values for this study: the population, the sample, experimental units, explanatory variable, response variable, and treatments. So 400 men between the ages of 50 and 84 are recruited as participants. The men are divided randomly into two groups. One group will take aspirin, and the other group will take a placebo. Each man takes one pill each day for 3 years, but he does not know whether he is taking aspirin or a placebo. At the end of the study, researchers count the number of men in each group who have had heart attacks. So, population, the sample, experimental units, explanatory variable, response variable, and treatments. What's the population here? Okay, so the first bullet point says 400 men between the ages of 50 and 84 are recruited as participants. So our population is going to be men between the ages of 50 and 84. The sample, now that's the smaller thing, the thing that we're going to work with, are the 400 men in the study. What are the experimental units? Those are the individual men in the study. The explanatory variable, that's the one that we're looking to see if it makes the change in the response variable. That's going to be oral medication. So in this case, taking aspirin or not taking aspirin or a placebo for this experiment. So then the response variable is the thing, did it change because of that? So we want to know whether the subject had a heart attack. The heart attack is hopefully responding to the oral medication. And then the treatments are like, what are we doing to the participants in the study? So aspirin or placebo, those are the things that they're taking. So it's important that the study investigate only the two variables. A confounding variable, we talked about this a little bit in the other section. Two variables are confounded when the effects of one cannot be distinguished from the effects of the other. They may be part of the study or they may be outside lurking variables. So an example is subjects who are put on an exercise program might also improve their diet unbeknownst to the researcher, and then improve their health in other ways not due to exercise alone. So then diet becomes a confounding variable. You don't know that it's happening necessarily, and it's affecting the outcome. A lurking variable is a variable for which no data have been collected, but that nevertheless has influence on other variables in the study. So an example would be a study involving just two variables, the amount of gasoline used to commute to work and time to commute to work. But then the level of traffic could be a lurking variable that increases both the amount of gas you use and how long it takes you to get to work. So they're similar, but also different confounding and lurking variables. So to prove that it's the explanatory variable that's causing the change in the response variable, the explanatory variable must be isolated. The experiment must be designed in a way that there's only one difference between the groups being compared, and those are the planned treatments. We don't want to, worry about confounding or lurking. or lurking variables. So to prove the cause and effect connection between the explanatory and response variables, the experimental units must be randomly assigned to the treatment groups. This way, all of the potential lurking variables are spread equally among the groups, and the only difference between the groups is the one imposed by the researcher. Therefore, different outcomes measured in the response variable can be a direct result of the different treatments. So we have to be careful because the power of suggestion can influence the outcome of an experiment. The expectations of the study participants can be as important as the actual medication. And so to offset this, researchers set aside one treatment group as a control group. And the control group is given a placebo treatment, a treatment that cannot influence the response variable, but knowing you're in the control group can still affect the outcome. So to get rid of that problem, blinding in a randomized experiment preserves the power of suggestion. It is when the subjects do not know if they're receiving the active treatment or the placebo treatment. And then a double-blind experiment is one in which the subjects and the researchers involved with the subjects are blinded. So sometimes if the subject knows what group they're in, that will change what the outcome of it. So then you take that away by blinding. But if the researcher knows what group the subject is in, that can also affect the outcome because they might treat the subjects differently, or they might treat they might just behave differently, So double blinding is when neither the subject nor the researcher knows what group the subjects are in. So here's another example. You're concerned about the effects of texting on driving performance. So design a study to test the response time of drivers while texting and while driving only. How many seconds does it take for a driver to respond when a leading car hits the brakes? So describe the explanatory and response variables in the study. What are the treatments? What should you consider when selecting participants? Your research partner wants to divide participants randomly into two groups, one to drive without distraction and one to text and drive simultaneously. Is this a good idea? Why or why not? Identify any lurking variables that could interfere with the study, and how can blinding be used in this study? So the explanatory variable is the presence of distraction from texting while driving, and the response variable is the response time measured in seconds. So we want to know if texting affects response time when you're driving. What are the treatments? The treatments are texting while driving and not texting while driving. So those are the two things that we're going to have subjects do, and then we're going to measure their response time. What should we consider when selecting participants? Age, driving experience, texting experience, all of these things could affect the response variable or their response time. Your partner wants to divide them into two groups randomly, one to drive without and one to text and drive. Is this a good idea? Why or why not? And when I first read this example, I was thinking, well, you should never text and drive. But they're thinking more about the study design here. And so here you want to think that drivers should be assigned both treatments in random orders, and then because they all have different abilities. So every driver would do drive without distraction, but then also with distraction, and then you would compare those times to see if it had an effect on that. Lurking variables could include the weather or age, driving experience, type of phone, things like that could also affect a driver's response time. So you have to be careful with that and try to isolate the variables that you're looking at. And then how can blinding be used in this study? Researchers could be blinded to which treatment is being applied. So you obviously can't blind the subjects. They're going to know if they're texting while they're driving or not, but you could have just those numbers with a numerical identifier that didn't say which one it was, and then the drivers could, you would know like which subject it was, and then there are these two response times, but you wouldn't necessarily know which one was this when you're collecting the data. So data collection techniques. We have observational studies where the researcher merely observes what is happening or what has happened in the past and tries to draw conclusions. An experiment is when a researcher manipulates one of the variables and tries to determine how the manipulation influences other variables. That's what we've been talking about so far. And then a survey, researchers gather data by asking participants questions, and the responses could be a simple yes or no, a number on a scale that represents their feelings. That's called a Likert scale. Sometimes you see that in a doctor's office about how your pain is, or an open-ended response, which the researcher must convert to a category or number. So surveys and potential pitfalls that we can have. Individuals, so non-response, individuals can not be contacted or refuse to participate. Non-response can result in a significant undercoverage of a population. The truthfulness of a response, respondents may lie intentionally or unintentionally, inadvertently. Faulty recall, respondents may not accurately remember when or whether an event took place. Hidden bias is when a question may be worded in such a way as to elicit a specific response. Vague wording in a survey, words such as often, seldom, occasionally, those mean different things to different people. Interviewer influence, factors such as tone of voice, body language, dress, gender, authority, and ethnicity of the interviewer might influence responses. Voluntary response, individuals with strong feelings about a subject are more likely to respond. So those are all things to think about when you're doing a survey. So some cautions about data. So here's an example. These are a bunch of examples and different things that could occur. So a uniformed police officer interviews a group of 20 college freshmen. She asks each one his or her name, and then if he or she has used an illegal drug in the last month. Like what could affect that outcome of that question, right? Just think about who's doing the asking, who's being asked. So some of these respondents might not answer truthfully because it's a police officer. Some may refuse to participate just because of the question or because of the person asking the question. Jessica saw some data that show that cities with more low-income housing have more homeless people. Does building low-income housing cause homelessness? So what could happen with this kind of, like what's going on here? There may be some confounding or lurking variables such as the size of the city. Larger cities may have more low-income housing and more homelessness. So this is also, we talked in another section about causality or causing something and just correlation. So one may not cause the other, they just might happen together, and that sometimes can be confusing. A survey about quality of food in the student cafeteria was conducted by having forms available for the customers to pick up at the cash register. A drop box for completed forms was available outside the cafeteria. So what could be some issues with the data here? So voluntary response will likely produce more negative comments. Like people might feel very strongly when they don't like something. And so those are the people that are responding. I also think, I don't think I put it in here, but like depending on where the drop box is, this says it's outside the cafeteria. So you may not feel, weird putting it in or awkward putting it in. Like if it was outside the cafeteria office where the manager was, you may not want to put your survey in there because that would be, undue influence kind of thing. And then extensive studies on coronary problems were conducted using men over age 50 as the subjects. Conclusions for men over age 50 may or may not generalize to other age and gender groups. These results may be useful for women or younger people, but studies specifically involving these groups may need to be performed. Okay. So ethics is really important when we're talking about surveys and experiments and studies and stuff. It can be, statistical information can be misrepresented and misused. It can be gathered and presented in ways that make it full of errors and inaccurate. So the textbook gives an example of a researcher who was found to have created data sets which largely confirmed prior expectations. They altered data in existing data sets, changed measuring instruments without reporting the change, and misrepresented the number of experimental subjects. That's just, there's just so many problems with that happened to this one. So you can look it up on the textbook if you're interested in it. But sometimes even the problem just lies with the lack of familiarity with elementary statistics. Professional organizations like the American Statistical Association clearly define expectations for researchers. There are even laws in the federal code about the use of research data. When a statistical study uses human participants, as in medical studies, both ethics and the law dictate researchers should be mindful of the safety of their research subjects. The U.S. Department of Health and Human Services oversees federal regulations of research study with the aim of protecting participants. Oversight committees can be created, known as institutional review boards. Key protections that are mandated by law include the following. Risks to participants must be minimized and reasonable with respect to projected benefits. Participants must be given informed consent. This means that the risks of participation must be clearly explained to the subjects of the study. Subjects must consent in writing, and researchers are required to keep documentation of their consent. Data collected from individuals must be guarded carefully to protect their privacy. And these ideas may seem fundamental, but they can be very difficult to verify in practice, whether they've actually happened or not. So another example, let's see if I can put my face somewhere else. Describe the unethical behavior, if any, in each example, and describe how it could impact the reliability of the resulting data. Explain how the problem should be corrected. So a study is commissioned to determine the favorite brand of fruit juice among teens in California. So A, a survey is commissioned by the seller of a popular brand of apple juice. Like, what could the problem be there? It might not be a problem, but bias could be introduced, or the results could be misrepresented to benefit the producer of the juice. B, there are only two types of juice included in the study, apple juice and cranberry juice. What could be wrong with this? Well, these are two very different juices, and researchers should compare different brands of the same type of juice, not ones that taste totally different. Researchers allow participants to see the brand of juice as samples are poured for a taste test. That could definitely influence people, and so this should be a blind taste test to not introduce that potential bias. 25% of the participants prefer brand X, 33% prefer brand Y, and 42% have no preference between the two brands. Brand X references the study in a commercial saying, most teens like brand X as much as or more than brand Y. So this was a little bit tricky, but look, 25% of the participants prefer brand X, 42% have no preference. So the commercial is putting those two together and making it seem like more prefer X, when in reality, more specifically prefer Y. You can't really consider the 42% that don't have a preference. So basic guidelines for planning a statistical survey. First, identify the individuals or objects of interest. Specify the variables as well as how you will measure them or observe them. Will you use an entire population or a sample? If a sample, which technique will you use to select it? Be sure to address issues of ethics, subject confidentiality, and privacy when collecting data. Collect the data. And then note any concerns you might have about your data collection methods and list any recommendations for future studies. So here's just a quick little table about the different kinds of data collection techniques. Surveys, these are the best choices for gathering information across a wide range of many variables. You can include a lot of questions. You have to be careful, though, in how you construct and administer the survey. Non-response and other issues discussed earlier can introduce bias when you're doing surveys. Observational studies is the next most convenient technique for gathering information on many variables. The protocols for taking measurements or recording observations need to be specified carefully. Experiments are the most stringent and restrictive data gathering technique. They can be time-consuming, expensive, and difficult to administer. The goal is often to study the effects of changing only one variable at a time in experiments, and the number of variables may be more limited, and they must be designed carefully to ensure that the resulting data are relevant to the questions. So that's the end of section 1.4 on data collection techniques and ethics. Thanks for watching.